Hey, welcome viewers, welcome to an amazing channel. Please always do well to share and do well to like and do well to comment. It's very necessary. So we have an amazing topic on the board. This topic has been a threat to a lot of students in the past and even presently. What we have now is set. Set. What is set? What is the mystery behind set? Set is just a collection of well-defined objects. A collection of well-defined objects. If they are not well-defined, it's not a set. So a collection of well-defined objects. The object can either be places, can either be name, can either be figures or anything like that. Can be either be gender. You understand? So it's a collection of well-defined objects. That is what set is all about. And take note, I can say the set of all students in mathematics department. The set of all students in mathematics department. This becomes set. Do you understand now? That is what set is all about. Okay, that will lead us to notation of set. Please take note. Set, capital letters. If you see something like this, A, sorry for that. Give me a marker, a very nice marker there. Yeah, the markers, okay. If I say A, if I say A, B, C, D, these are the sets itself. These are set itself. When I say A, B, C, D, these are the sets itself. So set is represented as capital letters. Why small letters? A, B, C, D. These are the elements of the set. These are the elements of the set. That means these are what is in the set. You understand now? We have Nigeria. If AAU is a set, Ambosali University is a set, if Uniben is a set, all the students that make up it are what we call the element of Uniben, element of Uniport, element of Ambosali University AAU. Do you understand that? Those are the elements. So the elements are represented as a small letter, small alphabet, smaller alphabet. While the set itself is represented as what? As capital letters, big alphabet. Do you understand now? That is for that. And then we have what we call the universal. The universal, this, we can call it either this or this. Let me wipe this. With that, we call it this or we call it this. This is what we call epsilon in mathematics. I can call it epsilon. Epsilon. This is the universal. This is the epsilon. So universal, this symbol is represented as universal, or you can call it this. Either you call it this or this. Do you understand now? That is for that. So that will lead us to what we call the specification of sets. Sets are generally specified in three ways. We have the statement, we have the listing, and then we have the builder form. We have the statement, we have the listing, and then we have the builder form. What is a statement? What is a list? And what is the builder form? If I say set of all natural numbers from 1 to 10, set of all natural numbers from 1 to 10, the listing is S equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 itself. What I just did now is listing. By saying it alone, set of all natural numbers from 1 to 10, that one is the statement. But by listing it out now, this is the listing. And I can, then the builder form, our builder form, I can say X, such that X, an element of Z. Do you understand how you call Z? An element of Z. Or you call it the natural number, an element of the natural number. And not only that, our X such that X 1 less than or equal to X less than or equal to what? 10. Such that our X is an element of what? An element of Z. What I just did now is a building form of the what? Of what I've been explaining. What I just did now, like I said earlier, is the building form of what? The building form of what I've been explaining. Do you understand now? This is what we call the building form. 1 less than X less than or equal to what? 1 less than or equal to X less than or equal to what? Equal to 10. This simply means that X1 lies ranges from what? 1 to 10. Do you understand now? What the builder form simply means that X ranges from 1 to 10. Do you understand now? That is just this. And that will lead us to the types of sets. That will lead us to the types of sets. We have the null set or empty set. The null or empty set. As the name implies, the null or empty set, these are sets that does not have elements in them. These are sets that does not have elements, that have zero elements, that does not have elements. That is what we call the null or the empty set. Do you understand? And then we go to the single set. Either you call it the singleton set or the single set. The single set, these are sets that has only one element. These are sets that has only one element. For example, I can say the set of months, the set of months that have 28 days in the year. The set of months that have 28 days in a year. What are the set of months that have 28 days in a year? We just have only February. Do you understand now? So February is a what? Is a single set. Do you understand now? February is a what? Is a single set in that very particular statement. Do you understand now? That is for that. And then we have what we call the finite and the infinite set. The finite set, these are sets that have n numbers. Or you can say these are sets that have n sets. When I mean n, I mean any number, any. It can be 1, it can be 2, it can be 3, it can be 4, it can be 5, it can be 100, it can be 1000. So these are sets that have n sets. Do you understand? Now take note. And then we also have the infinite set. The infinite set are sets that have that their sets are uncountable. Their sets are uncountable. You can't count the sets. That is what we call the infinite set. Uncountable sets. Those ones are what? Are infinite what? Are infinite set. And then we have what we call the universal set. The universal set is that set that contains all other sets. Is that which contain every other set. Nigeria is a universal set that has 36 other sets under it. Do you understand? 36 states which are sets under it. That is what we call the universal. So Nigeria is a universal set of the 36 what? Of the 36 sets or 36 states. And then we have the subset. The subset is a smaller set. Is a set. If A is a set, then B has the components of A. Let's say we have A. If A is 1, 2, 3 to 5, and then B is 1, 2, and 3. Take note, everything in B are also in A. Do you understand now? Everything in B are also in A. So B is a subset of what? A. Do you understand now? Everything in B are also in A. So therefore, B is a subset of what? Of A. That simply means that we have a mother and a child. If a mother is pregnant, the mother is what? Is a set. Why the child is a subset? Do you understand now? Because every features, every characteristics of the what? Of the mother is exhibited in the child. Do you understand now? So this is a set and this is a subset. So a subset is a smaller set. Do you understand now? That is just what we mean by subset. And that will lead us to equality set. Equality set is just sets that are equivalent. If two sets are proportional, if two sets are equivalent, if two sets are same, are what we call equality set. Take note. If I have a set A, if I have A to be A, I, O, let's just say from 1, 2, 3, 4, 5. And then B is equal to 5, 4, 3, 2, and then 1. Take note, this one was arranged orderly, and this one was not arranged orderly. This one is ascending order, and then the other one is in descending order. But they contain the same elements. So those two elements are said to be equal. Equality of sets. They are said to be what? They are said to be equal. What is in this set is also in this set. They are said to be what? Equality of set. Okay, and then the next we'll treat here is the operation of set. Operation of set. Operation of set. Of that. Okay, it's okay. So operation of set. Why treating the operation of set? We think of the interset. We think of the union, so on and so forth. What is the interset? We first treat the interset. The interset is represented in this symbol that look like N. We can say A intersect B. Okay. Interset is just simply what is common between A and B. What is common between A and B? Do you understand that? That is just interset. If I have A to be equal to 1, 2, 3, 4, and then let's say 5. I don't know what I love in 1, 2, 3, 4, and 5. And then B is, let's say we have 2, 3, 4, and then let's say 7. What is common in A and B is our intercept. So if I say A intersect B now is equals to what? What is here and is also in this place? We have 2, right? 3, right? And then we have 4. Do you understand now? So A intersects B now is what is common in what is in A and is also in B. Do you understand now? And I can decide to symbolize this as X such that our X is an element of A and our X is an element, and our X is also an element of B. This is what we call intercept. Do you understand now? What is in A and is also in B is what we call intercept. So I can decide to say our intercept here, A intercept B, is equal to this. X such that our X is an element of A, X is also an element of what? An element of B. That is what we call the intercept. And that will lead us to the union of sets. Union of sets. Union of sets is just simply in a simple form. We are not speaking grammar. In a simple form. Union of sets is just the combination of the sets. Making them rhyme. Let's say we have A union B, and then we have our A to be equal to, let's say we have 1, 2, 3, 4, 5, 6. Okay. Let's remove 3. Let's say we have 1, 4, and then we have 9. And then our B is equal to, we have 2, we have 3, we have 7, and then we have 8. Take note, our A union B will be equal to 1, 2, 3, 4, 5, 6, 7, 8, and what? And 9. Do you understand now? So we are just combining those cofactors. The one that is not here, we complement it with this one. Do you understand now? That is what A union B is. And we can say the building form of A union B is equal to our X such that X is an element of A, or this intercept is and this one is or. X an element of what? An element of B, or both. Do you understand now? Do you understand? That is A for A union B. And then we'll talk about our disjoint. Our disjoint, it just simply means that we don't have our A intercept, our A, which is, we have A intercept B now is empty. If we don't have anything in A, there is no common ground between A and B. It's called our disjoint set. Do you understand that? There's no common ground. They are just like that. And it's empty. It's what we call the disjoint set. Do you understand now? There's no factor here. We say A intercept B now, there's no common ground. It's a disjoint what? It's a disjoint set. And then we'll talk about the complement of set. What is complement of set? Complement of set is what is in the universal, but is not in the set. What is in the universal, but is not in set A? If A is a set in the universal, what is in the universal, but is not in set A, is called what? Our complement of set, and is represented by A complement. That is just that. And that will lead us to the difference of sets. The difference of set is just simply means that what is in set A, what is in set A, and is not in set B. So A, if we have two sets, we have A and B. What is in this, but is not in this. So the difference of set will just be A minus B. But take note, there is a law that A minus B now is not equals to B minus A. Take note. This is a law in the difference of sets. A minus B is not equals to B minus A. So difference of sets does not obey commutative laws. Do you understand now? That is for that. And then we also have the power of set. This aspect of matter has been a kind of complicated thing in students, most especially in Nigeria. What's the power of set? What does it mean? What does it entail? Look at it now. Okay. The power of set. The power of set is represented as power of set is equals to 2 raised to power n. This is the cardinality of it. We can say power, let's say we have A to be equals to A, B, C. Let me use A, B, and C. The power of A, of set A now, is equal to, take note, power of a set simply means everything that comprises of the set. And everything that comprises of the set simply means an empty set is inside the set itself. Take note, when you go higher, when you are learning algebra or topology in mathematics, you get to understand that a set is a subset of himself. A set is a subset of himself, of itself rather. Do you understand now? That is for that. So in this place now, we also see that a set is a subset of himself. So everything that comprises of the set is what we call the power of the set. Then take note. Let's look at this now. The power of this set is, remember I said an empty set will be involved. Then take one, A. Then we have B. Then we have C. We have C. And then we have what? A, comma B. We have A, comma C. And then we have B, comma C. We have B, comma C. And then what is next again? Do we have any other thing again? No, we don't have any other thing. So we take A, B, and then what? And then C. So let's count all of these now. We have 1, 2, 3, 4, 5, 6, 7, and then 8. But take note, we are told that the power of a set, which is power of A now, A has three elements in it. So we have 2 raised to power what? 3. 2 raised to power 3 now will give us what? 8. And when counting all of these now, we have 1, 2, 3, 4, 5, 6, 7, and then what? And then 8. So everything in the set, everything that comprises of the set is called what? The power of the set. Okay, that will lead us to the laws of set. That will lead us to the laws of algebra of set. The laws of algebra of set. Okay, can wipe these out. The laws of algebra of set. The laws of algebra of set. The law says that if A union A is equals to A. And take note, this is what we call the idempotent law. You might ask that A union A or A intersect A. What laws are that? A intersect A is also A. This law is idempotent law. Idempotent law. I took our time to actually write them on the board there.